previously we had looked at using the sine rule to solve for missing side lengths and missing angle sizes in non-right angle triangles. Right, so this is the second part of that lesson in which we're going to focus on the cosine rule. Right, so the very first thing, obviously, I want to focus on labeling sides again. So we label the sides with lowercase alphabets and we label the angles with uppercase alphabets. The cosine rule, obviously there are rules for all the sides and all the angles, as you can see in this picture. Now my preference would be to use the formula in this particular format if we are trying to find the side lengths, right? And I would prefer you guys to use the formula in this format if we are finding the size of a missing angle, right? Now yes, you can have all three of them down, but you know it's easy to see patterns. So we have a squared equals b squared plus c squared minus 2bc cos of angle A, right? And if you can follow the other two formulas, you'd see that the formulas basically have a pattern in them. So if you remember one, you should be able to work the other two ones out, right? Now, like we did with sine rule, right, we're going to talk about when are we going to use the cosine rule, right? So the cosine rule is basically comes into place when we have the length of all the three sides. So when we have all the three side lengths given to us, or when we have two sides and an included angle, right? Included angle refers to the angle in between the two sides. Right, so for example, if I go back to this particular diagram, right, angle A is the included angle for sides B and C, right? Similarly, if I look at angle C, it's the included angle for sides A and B. Alright, so we use the cosine rule under two conditions. One is if we're given the length of all three sides, and the second option is when we have two sides and an included angle. Right, we're going to jump straight into the examples here. Right, so the first example is asking us to find the unknown length correct to two decimal places x in the triangle given below. Right, so obviously in the triangle that has been given to us, right, there are two angles, right, and they've given us two sides, right? Now if I compare it with the two dot points that we have here, right, when we have two sides we need an included angle to use the cosine rule, right? And obviously, as we can see, the two other angles in the triangle are given except for the included angle, right? This is where we can use the property of a triangle, right? All three angles add up to 180. So 33 plus 47 degrees is going to add up to 80 degrees, right? So the missing angle is going to be 100 degrees, so 180 degrees in the triangle, so for the missing angle is 100 degrees. So now that we have two sides in the included angle, we can now go ahead and solve for x, right? So x squared equals 4000 squared plus 2000 squared minus 2 times 4000 times 2000 times cos of the angle in between, which is 100 degrees, right? So if I put that into my calculator, squared plus 2000 squared, take away 2 times 4000 times 2000 times cos 100, right? I'm going to do Control Enter. Now obviously that's a big number. I'm not going to bother writing that down because the solution for x is going to be the square root of what we get here, because this formula, the cosine rule formula, basically represents how we're going to calculate x squared, not x, right? So therefore we're going to take a square root of that answer, right, which is what I'm going to do here. I'm going to take the square root of the answer from the previous step, right? That way I'm avoiding any rounding errors. So the length of the missing side x correct to two decimal places is 4772.67 millimeters, right? And that completes that question, right? So we've used the cosine rule to solve for a missing side length in a non-right angle triangle. Alright, moving on to a second example, right? This time they're asking us to find the largest angle in the triangle below. Now this has been a common question in the past VC exams, right? So when the question is asking us about the largest angle, so the largest angle is going to be right in front of the largest side, or opposite to the largest side in the triangle. So in this triangle that we have here, the largest side length is 8 meters. So therefore, the angle that we're going to be finding is going to be this one here, right? So if I was to quickly label my triangle, so capital A, B, and C, right? That's going to be my side A, side B, and side C, right? So we will be now finding the length of the angle A, right? So if I write down my formula for finding angle A, so cos A equals, so that is where, this is where the formula comes down from, right? So cos A equals B squared plus C squared minus A squared divided by 2BC, right? So I'm going to substitute the value, so cos A equals, right, so 5 squared plus 6 squared minus 8 squared divided by 2 times 5 times 6. Now, like we did with the sine ratio, as well as when we dealt with right angle triangles, the only way we can find missing angles is by doing the inverse function in the calculator. So the cos inverse of the answer that we're going to get from this particular step. Right, so what I suggest you to do is I suggest you to do it all in one calculation in your calculator, right, thereby avoiding any rounding errors that you might have, right? So the cos inverse option, right, I'm going to create a fraction there, so 5 squared plus what we have here, 6 squared minus 8 squared, 6 squared minus 8 squared divided by 2 times 5 times 6. Control enter gives me the value for the angle is 92.87 degrees, right? And again, the most common rounding they expect when it comes to the angles is to the nearest degree. So that angle is going to round up to the nearest degree as 93 degrees. And right, that's how we use the cosine rule to work out the missing angle in the triangle, right? Another thing I forgot to point out before we started this question is, obviously, why are we using the cosine rule in the first place, right? And the reason for that is we have been given the 3 side lengths, and that's the reason why we're using the cosine rule, like it's mentioned in the dot point that we took down at the start, right? So when we have the length of all 3 sides, or when we have 2 side lengths and an included angle, we can go ahead and use the cosine rule to find the missing side lengths or angle sizes. Right, thank you for listening, folks, and have a wonderful day.